Okay, let's have a look at number 2. Yes? No, because I still have number 3 to do. Yeah? Number 2? Yeah? So, in a factory, products are tested before they're shipped. 98% are good, 2% are bad. And the equipment is known to be inaccurate, and if a faulty component is tested, the probability it will pass the test is 0.03. Okay, so what you've got happening here is this factory is making something. It doesn't matter, TV, iPhone, iPad, whatever. And when it makes it, 2 things can happen. It can either be good and it works, or it can be broken, it can be bad. So in this question we're told that 98% are good, but 2% are broken. Yeah? Does that make sense? Now, what you can then do is after you make the toy or the iPad or whatever, you can test it to see if it's working or if it's broken. Yeah? So, if it's good, it can either pass the test or it can fail the test. And if it's bad, it can either pass the test or it can fail the test. Now just think for a moment. Do you think this number here will be big or small?
Big.
Very good. Why?
Because it's pass and it is good.
If it's good, it should pass.
Yes.
And in fact, the question says that if it is faulty, then the probability it'll pass is 0.03. If it is good, the probability it fail is 0.01. So this is 0.01, so this is 0.99. Now, if it is faulty, if it is broken, the probability it'll pass, okay, so should this be a big or small number? Small. And it is 0.03, so then this number here is 0.97. Okay.
Why not 0?
Well, this is because when you do a test, like when you go to the doctor
Yes.
and do a test, no test is perfect. It'll always make some mistakes sometime.
Okay, but it shouldn't pass. I make the test and I got it bad, okay? Right? I do the test and the statistics
But
bad.
in the real life, every test can fail sometimes. So like for example, yeah, well for example, like if this was food, and maybe you open the box and the food looks good and you think it passes, but then maybe the bad food is at the bottom of the box. You know what I mean? Like every test, there's always a chance of a mistake.
Yes.
Yeah? So never actually 100%. Yeah? Okay. So do we understand the probability tree? Alright. So the first question is draw the tree, which I've done. What is the probability of a good component passing the test? So what's the probability of good and pass? No, sorry. What is the probability of a good component passing the test? We have the answer already. Probability a good will pass. That's equal to 0.99. Notice, because of the word will here, please notice the difference here. Good and pass. Good will pass. What's the difference here? Yeah, what is the difference, Karar, if you can explain it?
Something good should pass, will pass, okay? I said it had I will pass.
Well, let's keep it more English grammar difference.
Okay, English grammar,
Yeah.
good and pass.
Yeah, what's the difference between good and pass and good will pass?
Multiply.
Yeah, but go on, Fahad. I want an English reason.
because it's like two things, good and pass,
Yeah,
and in the second one it's the good will pass.
yeah, but explain the
And
difference.
the object will pass the test.
Let me help you out.
How is it?
This one, yeah, but you're just saying the same sentence. I want like,
It's good and he already has the test. It's good and then will have. Right.
correct, yes. See?
A plus.
A plus in English. Yes, you're right. So this one here is both in the future, whereas this one has happened in the past. You know it's true, and you want this one for the future. So you know it's good.
Excellent.
Excellent. Yeah, so you know it's good. You want this one. 0.99. Okay. What is the probability that a component will fail? So that's the probability of a fail. Will fail. And it doesn't say if it's good or bad. So that will equal 0.98 times 0.01 plus 0.02 times 0.97, which equals, what's this? What is it?
I don't know, I wrote the from first.
Can I have the number, please?
0.029.
The C one?
It is equal to 0.292.
0.0292.
Okay. Okay, D. So what is the probability that it is bad, it's faulty, if it failed the test? Okay. Now this one here, this is a rather interesting one, especially it should be for you, Karar. So the question is, what is the probability that's broken if it failed the test? So you might think, oh, it failed the test, so that means it should be broken. But this isn't always the case. Sometimes things which are broken or not broken pass or fail the test.
So it would be like 0.0.
So it should, well, tell me what you think, guys. Do you think this will be big or small? The probability it's broken if it failed the test.
Oh, it would be high.
It should be high, shouldn't it? It should be like 0.99 or something. Yeah. So let's calculate it. So we'll split it up again. Here we can have failed and passed. And then here we can have
It's not said in the question of if.
well, it says given that, which means if. Grammatically, it's the same thing. Sorry, maybe I should point that out. Another English thing. Given that means if. So, if you ever see given that, it also means if.
But in the point,
I think that it says given that.
yeah.
So, if it passes, what is the probability that it is faulty? Oh, I'm sorry, I misread it. If it passes, okay. Sorry, I'll fix that up. Alright, so let me ask the class again. If it passes the test, what do you think the probability is it's broken? It should be small, like 0.01. Okay. So we have fail, pass, and we have good and broken. Okay, can somebody give me, actually, Fahad,
Yep.
you can calculate here failed and it's good. Tekken, can you do failed and bad? And then Grace, can you do pass and good? And then Sohi, can you do pass and bad? And then Amanda, you can add them together and make sure it adds to 1. Okay, so
9.8 into
No, don't give it to me as a percent. Actually, give it to me as 0 point this time.
It's minus 3 times 10 minus 3.
Oh, it's tiny, is it?
Yeah.
Okay, well then give it to me as a percent. Then what is it?
0.09.
Yeah, it's really, really small, is it? Oh, japers.
0.09.
It's not even 1%. All right, it's tiny. It's 0.98%. Okay. Who was next? Who was doing failed and bad? Yeah, what did you get?
0.99.
So 99%. Okay. Who was doing past and good?
0.9002.
So 97.02%. And then final. Wait, hang on. I can see this is not going to add up to.
Yeah, of course.
It doesn't matter. I don't even know if it should add up to 100.
You said it.
Yeah, the last one. Wait, who said 99 here? Failed and bad.
You said that.
No, he said. You said 99, didn't you? 0.99 or 0.99%?
0.99.
For failed and bad? Ah, no, that's too big, Tekken.
0.0194.
That sounds better. My goodness, I can't. All I need you to do is type numbers on a calculator. Why are you making my life difficult? Right, I'll do it. Good and pass will do. Good and pass. Good and pass. 0.97.02%. Is that what you said, Grace?
Yes.
Congratulations to you. Good and fail. 0.98 times 0.01. 0.98%. That's what you said, Fahad, isn't it?
Yeah.
Bad and failed.
That was taken.
1.94% Tekken. And then Sohi, bad and pass, what did you say?
6 times 10 to the minus 1.
It's tiny number, yeah?
It's
2, yeah. Yeah, it's 0.06%. Now, Amanda, please.
100.
There we go. It's not so difficult once you use your calculator correctly. Right, so this table is okay, yeah? So now we can answer the question, what's the probability that it's bad if it passes the test?
Pass.
So
0.02.
it passes the test, so we're only here. So the probability it's bad is 0.06 over 97.02 plus 0.06. What do you get here? Yeah? What did you get, Sohi? Hang on, let Sohi there shoot. Yeah, go ahead, Sohi.
6.18.
Yeah.
Times 10 to the minus 4.
Is that a percent? Oh no, that's a probability. Yeah. So as a percent, that would be, oh my goodness, it'd be this would be a -2. It'd be 618%, which is tiny. It's not even 1%. You know, it's like 1/25
Half one.
of a percent. No, it's not even half a percent, because half a percent would be 0.5. So it's absolutely a tiny number. But this is what we thought it should be. Yeah. Okay, and the last part, E.
But this makes sense.
Yes, it does.
Yes, it does.
If it passes the test, it shouldn't be broken.
Yeah.
Yeah. All components that pass the test are shipped to the customers. So now this is a very interesting question. The last part here is, you have 5,000 of these,
Okay.
and these 5,000 of them, they all pass the test.
All pass this.
How many of them are actually broken? So you can use this number here to get the answer.
Multiply.
Yeah.
Percentage.
Percentage. So in fact you want 0.0618% of 5,000.
Divided by this divided by 100 and
Yeah.
multiplied by 5.
So of the 5,000 parts or toys or whatever they are, only 0.0618% will be broken. So 0.0618% of 5,000 is 3.09. So roughly 3 will be bad of the 5,000. Yeah. Okay, that was part E. Now number 3.